Welcome back, everyone. Today, we're really diving deep into something I know you've been excited to discuss. Machine learning, specifically looking at how it's really shaking things up in the world of supply chains.
It's really fascinating. We're seeing these incredible advancements, and it's interesting to see how quickly they're moving from, just theory and research into actual real-world applications.
Yeah, absolutely. And speaking of advancements, the lecture we're looking at today from Georgia Tech really jumps right in, doesn't it?
Yeah.
Professor Caputo kicks things off by comparing the potential of AI to, well, electricity.
Right out of the gate. It's a bold statement for sure.
It definitely made me pause and think, okay, we're not talking about just minor tweaks here. This is about fundamental change.
Yeah, he's really highlighting the scale of the impact AI and machine learning are expected to have on, well, pretty much everything. And we can already see it happening. I mean, look at self-driving cars. Companies like Google, Tesla, even Uber are leading the charge there, not necessarily the traditional car manufacturers you might expect.
It's really interesting how that shift is happening, right? It's becoming more about software than the actual hardware, in a way.
Exactly. And that software, that's where the machine learning magic really comes in. It's changing the entire game.
It really is. But of course, there's always a but, right? He also talks about all the hype surrounding AI and machine learning. So how do we cut through all that noise? How do we separate the real breakthroughs from, just trendy buzzwords?
He makes a really crucial point about not getting too caught up in the hype and dismissing the technology because of it. There's this idea of the accelerated Pareto principle. Essentially, it suggests that a very small number of companies, think tech giants, might end up controlling a huge chunk of the AI landscape.
So almost like a monopoly on artificial intelligence.
In a sense, yeah. He even uses the term AI arms race to describe what's happening, which is both intriguing and, a bit concerning.
Definitely something to keep an eye on as things develop. But let's get back to those real-world applications for a bit. One thing that struck me, I've always thought of AI as, well, not very creative. But then Professor Caputo shows that neural network recreating that same image in all those different artistic styles like Van Gogh and Picasso. It was incredible.
It really makes you think, doesn't it? Whether you call it true creativity or not, the level of stylistic imitation and learning the network demonstrated is really impressive.
Yeah, it definitely challenges our preconceived notions about what AI can and cannot do. And on that note, he also touches on some of the challenges, especially the potential impact of AI and automation on the workforce, right?
Absolutely. It's a big one. And it's something we see directly in supply chains. One of the key applications of machine learning there is in something called dynamic routing.
Dynamic routing.
Yeah, imagine delivery routes that aren't static. They're not just fixed plans. They adapt in real time to traffic, accidents, road closures, even weather conditions. It's all constantly changing.
Wow, that sounds incredibly efficient. How does that even work? What's going on behind the scenes to make those adjustments on the fly?
So it's all thanks to these things called online learning algorithms. They're constantly analyzing data, real-time traffic updates, weather reports, and they're optimizing those routes on the fly. It's pretty amazing. Some companies are seeing huge improvements, like a 15% decrease in delivery times.
15%? That's huge. So it's not just about speed, though, right? It's about making the entire process much smarter and more adaptable.
Exactly. And it's not just about the deliveries themselves. Professor Caputo also talks about how machine learning can help assess worker performance, especially in places like fulfillment centers, which are becoming increasingly crucial to the whole supply chain.
Yeah, it's one thing to optimize the routes, but what about the people actually doing the work? Traditionally, you might just measure someone's performance by how many items they pick per hour or something like that, but Professor Caputo is suggesting something a lot more nuanced, right?
Right. Machine learning allows us to go beyond those simple metrics and get a much more complete picture. Things like how difficult were the tasks, how big were the orders, even factoring in individual worker fatigue can all be taken into account.
It's like a whole other level of understanding what impacts productivity. And like you said, it's more than just the numbers.
Exactly. This approach, using machine learning for a more holistic view of worker performance, it benefits both the company and the employees. It's really fascinating stuff.
It's really amazing when you think about it, how much more information you can get, how much more efficiently you can analyze things with the help of machine learning. And speaking of gathering information and making it work for you, Professor Caputo also dives into inventory management in this lecture, which I'll admit I wasn't expecting to be so hooked, but it's really interesting stuff.
Yeah, it might not sound as exciting as like self-driving cars or something, but inventory management, it's the backbone of any business that deals with physical products.
Yeah, absolutely. And what's fascinating is how it's being transformed. Professor Caputo talks about this shift from using static inventory models to these much more dynamic learning
Yeah.
systems. He even uses the term, get this, deep reinforcement learning.
It sounds pretty intense, right?
Yeah, it does. So how would you explain that, deep reinforcement learning, especially in the context of, managing inventory? What does that even look like?
Okay, so imagine a system that learns from its own actions and the feedback it gets over time, right? Instead of just relying on some fixed set of rules that someone programmed into it.
So it's not like, if this happens, then do that. It's more adaptable than that.
Way more adaptable. Think of it like, and this might sound a bit strange, but think of it like teaching a robot to ride a bike. You wouldn't hand the robot this long list of instructions, right? You let it figure it out. It would try, it might fall, it would adjust. And through that process, it would learn.
So it's learning by doing, essentially, through trial and error, but on a much larger, more complex scale.
Exactly. And the beauty of it is that it can handle a lot more complexity. It's not limited by our ability to program in every possible scenario. It can adapt to changing conditions, like, say, there's a sudden spike in demand for a certain product, and it can adjust the inventory accordingly, much more dynamically than we could ever do manually. In the lecture, Professor Caputo gives this great example of a company, I can't remember their name off the top of my head, but they use this type of system to predict these huge fluctuations in demand, like way ahead of time, and they were able to adjust their orders proactively, completely avoided these potential stockouts during their busiest seasons. It was incredible.
That's amazing. So it's almost like having a crystal ball for your supply chain, in a way.
Right. You're not just reacting to what's already happened. You're anticipating what's going to happen and getting ahead of it.
It sounds incredibly powerful, but, and I'm sure there's a but here somewhere, but he also mentioned that one of the biggest challenges with these more sophisticated, deep reinforcement learning models is that they need a ton of data to actually be effective.
Yeah, that's definitely a hurdle. Machine learning models, especially the really complex ones, they're incredibly data hungry. They need massive amounts of information to learn from, which isn't always easy to come by, especially in the fast-paced world of supply chain management.
So where do you even get that much data if you're just starting out with this? Or, if you're working with a supply chain that maybe hasn't been using these types of systems?
That's where the power of simulation really comes in.
Simulation, like creating a virtual version of your supply chain.
Exactly. It's like a virtual sandbox where you can test these algorithms, train these models in a safe environment without having to risk disrupting your actual operations. It's like those flight simulators that pilots use, but instead of planes, it's your entire supply chain you're simulating.
That makes a lot of sense.
Yeah.
It's a much safer way to experiment and refine these models.
Yeah.
But is there a risk? I mean, could a model that's been trained in a perfect virtual world not perform as well when it encounters the messiness of the real world?
Yeah, it's a valid concern. There's always a chance that a model trained in a simulation might not translate perfectly to real-world scenarios. There could be variables, unexpected events, external factors, things that weren't accounted for in the simulation. And that's something that Professor Caputo emphasizes as well. He talks about the importance of what he calls robust training to overcome this
Robust training. So like tough love for algorithms.
Yeah.
What does that entail?
Basically, you're trying to make the model as resilient as possible, able to handle variations and uncertainty. So going back to the flight simulator example, it's not enough to train the model in perfect weather conditions, right? You have to throw in some rain, some wind, maybe even some snow just to make sure it can handle those challenges.
So you're exposing it to all sorts of potential problems to make sure it can adapt.
Yeah, you're toughening it up, basically. And by doing that, by incorporating that robustness into the training process, you're increasing the likelihood that the model, once it's deployed in the real world, in an actual supply chain, it'll be able to handle whatever gets thrown at it. Because as we know, unexpected events, disruptions, they're bound to happen.
So we've talked about training these models in these really complex simulations, getting them ready for the real world and all its unpredictability. But what about actually putting them to work? How do you even begin to integrate these, they're pretty cutting edge, into existing systems? A lot of companies have, been using the same systems for years.
It's a huge question, and it can be a major roadblock for companies, They see the potential of these tools, but then the thought of actually having to implement them, it feels overwhelming. Like, are they going to have to rip and replace their entire infrastructure? It can be really daunting, not to mention expensive.
Yeah, starting from scratch is not really an option for most businesses.
Right. But the good news is, and Professor Caputo really highlights this, a lot of these machine learning solutions, they're designed with that in mind. They're built to integrate, at least to some extent, with existing systems. It's not always going to be completely seamless, but it's not like starting from zero either.
That's really good to know for anyone listening who's been putting off exploring these tools because of that fear factor. And it speaks to what we've been talking about this whole time, making these solutions practical. Because what good is cutting-edge technology if you can't actually use it? Right?
Exactly. Professor Caputo is a big proponent of that. It's not enough to just have the most advanced algorithms. You have to be able to implement them, to make them work within the constraints of the real world, existing infrastructure, established processes, all of that.
Absolutely. And speaking of the real world, one thing that really stood out to me was when he talked about the need for speed, for being able to adapt quickly in today's business environment. It's not enough to just be efficient anymore. You have to be agile.
It's true. Things change so fast now. And the old way of doing things, relying on historical data, making decisions based on what happened in the past, it's just not fast enough anymore. But that's where machine learning really shines. These algorithms can process huge amounts of data in real time, and that allows for a much more proactive approach. You're not just reacting to events as they happen. You're anticipating them, even predicting them.
It's like having a crystal ball almost, knowing what's coming before it arrives.
That's a great way to put it. And that ability to be able to not just keep up, but to actually get ahead of the curve, that's what can give businesses a real competitive edge.
Absolutely. And, thinking back on this whole conversation, there's this one thing Professor Caputo said that I think really sums it all up perfectly. He asked, how can we combine the power of machine learning with human expertise? And that's really the heart of it, isn't it? It's not about replacing humans with machines. It's about finding ways for them to work together to complement each other.
Couldn't agree more. And it's a question that extends far beyond supply chains, right? It gets at this bigger question of how we envision the future of work, of innovation, of how we as humans interact with increasingly sophisticated technology. It's a balancing act, for sure, but the potential is really exciting. That's what makes these conversations so fascinating.
And on that note, I think we've done our due diligence for today. We've covered a lot of ground, explored some really fascinating ideas about machine learning and its impact on supply chains, but also on the bigger picture. Hopefully this has sparked some ideas for our listeners, giving them some things to think about.
Definitely. This field is constantly evolving. There's always something new to learn, which is what makes it so exciting. It's a journey, and we're all figuring it out together, one algorithm at a time.
Well said. To everyone listening, thank you for joining us on this deep dive. Keep asking those big questions, keep exploring, and we'll catch you next time as we delve into another topic shaping our world.